Okay, this is, for example, an example of a step down transformer. In the input, I have a 120 volts AC, and in the output, there are different possibilities. 60 volts between this and this, 40 volts between this and this, 20 volts between this and this. Yeah, it's a step down transformer. This is the example. Look, internally in the circuit board of the inverter, you have a transformer. And in the transformer, in the input, you have a DC current, and in the output, you have a 220 or 120 AC, because this is a step-up transformer, This is a typical example. You have more step-up transformers in other equipments. For example, internally in amplifiers, a lot of electronic equipment, electronic devices, they have step-up transformers. This is a transformer, a step-down, equal to this, step down, exactly like this one. We are going to use this one to check if your rectifier is good. I am going to connect in the input 120, and I am going to be ready. I connect female terminals for positive for my output. This one, the input is 120 and the output is 28 volts AC. The example is this. Suppose that I have in the primary coil, this is the primary coil, the voltage, the intensity, and the number of coils. The voltage is 1000 volts in the primary coil. The intensity is 2 amps in the primary coil. And the number of coils in the primary is 50 turns. And I know about the secondary coil only the intensity. The intensity is 10 amps. The question is, how much is the voltage in the secondary and how much is the amount of coils in the secondary? We are going to use a simple formula to calculate that. In this particular case, I have an isolated transformer. The isolated transformer, remember, have equal coils, equal turns in both sides, in the primary and the secondary, equal amount of coils. What is the meaning of that? That if I have 120 volts at the input, I have 120 in the output. If I have 240 in the input, I have 240 in the output. According with my recommendation, the isolated transformer should be located in between the switch selector and the main panel. Why? Because in this location, I clean the signal coming from generator, or coming from inverter, or coming from short power. All of those 3 signals are cleaned, and the signal will be completely clean in the output of the isolated transformer. Okay, what is the procedure to do the wiring with transformers? If I have a transformer like this, suppose that this transformer is a single phase. This is a typical transformer single phase, and I am going to do the wiring right now. This is the input, this is the primary. In the primary, I have the hot and the neutral coming in. Suppose that the hot and the neutral coming in is 120 volts, 60 hertz. If I have the same amount of coils in the secondary, of course, I have 120. And this is the neutral, and after this point, this end will be hot line, and this end will be the neutral. The procedure to wire a double phase transformer is like this. This is the input. Phase number 1 is black color, phase number 1. In this point, finish the phase number 1 and continue. But in this point, touch the frame and is connected with the neutral. Remember, only at the source of the power. And continue the second phase. Okay, this is phase 1, the red one. Continue. Phase 2, and this point is the neutral point. That's the neutral point. In the output, I have exactly the same. Phase number 1, finish here, and continue here. Phase number 2, and this point in the middle will be the neutral.